Hello everyone. Today's topic is the half wave rectifier. The voltage that coming in your household is 220 volt 50 hertz source. This is 220 volt RMS voltage, and but your charger, your mobile charger, your laptop chargers, and other devices require a DC source. So how to convert this AC into DC is the first circuit we require. So in this laptop charger or mobile charger, the first thing we require is transformer, because the voltage that is coming in your household is 220 volt 50 hertz alternating current, but the requirement of the DC is 15 volt or 5 volt or 10 volt or 12 volt. So first thing we require is the transformer, a step down transformer to reduce the voltage. Okay, and then we require a rectifier circuit, okay, which convert this alternating current into pulsating DC current. This is not completely DC, this should be pulsating DC. Here it is written that AC source into pulsating DC source will convert. Okay, so the purpose of the half wave rectifier is to convert AC voltage into DC, pulsating DC voltage. You can see this is not completely DC. What is AC or DC? Okay, so the DC value of any signal, any volt waveform, is the area under the over the one time period and divide by time period. Okay, so if you find the area over one time period, this is sinusoidal wave. If you calculate the area, so it will some area at plus in the positive direction and some area, same area at the negative direction. So overall area, if we calculate overall integral or area, we will calculate over the time period is 0. Hence the DC value is 0. So this is pure AC signal. Okay, this is pure AC signal. But here if we calculate the area over one time period, it will not be 0. It will give you some value. Okay, and hence its DC value is not 0. It will give you some DC value and also some AC value, because it has some fluctuations also. Okay, so this is pulsating DC. Okay, so what happened in the half wave rectifier? We require an AC source, we require a diode, a resistor, a ground. Okay, so we will apply a AC signal and we can see the output will give you such kind of waveform. So let me show you, demonstrate by drag and drop model. Suppose this is an AC source, this is 1 kilohertz source. If I double click, it will show you. It will show you. Here is the voltage, frequency, you can vary. Okay. Second thing you require is diode. Let's search for diode. Here is the diode. I'll rotate it. Then you need a resistor. Here is the resistor circuit, resistor component. Okay. Now we have to connect just by click on these ends. So we have to check the voltage at input with respect to ground and at the resistor, and here voltage with respect to ground. You have to check. You have to compare what is the voltage here at the sinusoid source and what is the voltage across this resistor. Okay. So let me run this. I'll Connect oscilloscope channel 1 here and oscilloscope channel 2 here. Okay. You can see this is the sinusoid input and this is the output voltage, which you can get from this circuit. So this is the why it is not completely give this cycle, this positive cycle, because all practical diodes have some cut-in voltage. If all of them have some cut-in voltage, this much voltage is reduced. So if you increase this voltage value, so you can see if I click here, it will show you this maximum voltage is 3 volt and minimum voltage is minus 3 volt and frequency is 1 kilohertz. Okay, so now click here, you can check maximum voltage is 2.26 volt, 3 it is almost 0.7 volt less than that of input voltage. Why this much reduction? Because this diode having cut-in voltage approximately 0.7 volt. Okay, so this is the drag and drop model, but in the lab you will not get this kind of environment. This is just a simulation part. So you need a different environment. You have to perform this experiment by using breadboard, the practical diode, physical diode, and resistor, using oscilloscope and function generator. Okay, so let's close this application, and now we have to open Tinkercad. We have to go on this circuits. We have click on this circuits. Now go to create new circuit. Create new circuit. So first change the name by double clicking on this. This is half wave rectifier experiment. Let's change its name, rename it rectifier, half wave rectifier, and then enter. Okay, so first thing we require is breadboard. So either go through all menu. Okay, here you can get breadboard, 840 pin breadboard is available in your lab. Just drag and drop here. Then second thing you require is the function generator. Function generator to generate AC source. Okay. So again you can go all menu and search for the power source function generator. Here is the function generator. You just drag and drop here. Then you require oscilloscope. One more oscilloscope, because here in the Tinkercad this is not dual channel oscilloscope, so you require two different oscilloscope, one for input, one for output. Okay. Now you require circuit components like diode. Just type this diode. You require basic PN junction diode. Just rotate it by clicking on rotate button. Okay. So this black portion, as I told you, is anode, and this silver section is cathode. Okay, you can see. Connect this Now you require a register, basic components like register, rotate it. You have to connect a register, because register should be in series. Okay, so let's see, this is the voltage. Okay, so this is connected in series. Now through the function generator we have to apply some voltage at the diode anode. Let's give the red color, and this register to the ground. Okay, we generally make ground a single ground in the circuit, so this entire line is grounded. Now make it black. Okay, because entire circuit's ground should be same. So connect all negative or ground oscilloscopes ground. Make it black. In this red section. Now first thing we require is to connect at the input. So the first oscilloscope should be connected as input. Okay, so just connect this at input. So this is my input oscilloscope, and this one should be connected through register. Okay, but register is not grounded yet, so we have to ground it by connecting it to the any point on this line. It will be grounded. Now the circuit is completed, though it looks quite complicated, but circuit is simple. When you will make, you will learn. So let's run this simulation. Okay, you have to apply this sinusoidal source. You can change the parameter by double clicking on the function generator. Here the frequency we will generally use 1 Hertz. Okay, and amplitude 5/4, DC offset is 0, and we will apply sine wave. Okay, let's see the output. So this is the sinusoidal wave, you can see. Okay, and this is the output. You can increase the frequency to 5 Hertz. So you can see this is the sinusoidal source, and it is the rectified output here. Okay, now you can calculate the peak value is 5/4. So what is the peak value of this one? You can see clearly that it is reduced approximately by 0.7 volt. Okay, so this is the way you can connect the diode circuit, and you can get the information like peak voltage. What is the peak voltage of the input? What is the peak voltage of output? What is the frequency of input? What is the frequency of the output? You can calculate. Okay, we can also change the other functions, like by double clicking here I can change it to square wave. You can also see the output. This is the full cycle. It is also available positive, negative, but it has only positive cycles. There is no negative cycle. Okay, so this is converted. The circuit converts the AC signal into pulsating DC signal. Okay, thank you.